All right, Algebra 2, this is the sum or difference of two cubes. Okay, so we're going to first start off with factoring the difference of squares, just to kind of remember what that was. But the most important rule in factoring is if there is a greatest common factor, okay, factor it out first. Now, there's one little tiny caveat to this, is unless your terms are perfect squares or cubes, okay, then you might want to see how it pans out using the factoring ways that we talk about here. And if that doesn't yield anything, or if in doubt, go back and factor out the GCF. Okay, so go back to your first step. So a polynomial is completely factored when it is written as a product of two or more polynomials with integers as coefficients. Now this also means that there's nothing else that can be factored out of those binomials. So let's go ahead and take a look at reviewing factoring the difference of squares. Okay, this review is from before winter break on the difference of squares, so if you want to look back at your notes you can do that, that's fine, or you can look up a video. I'm going to show you a few of them now, but if you still need some more help, just go ahead and look up a video for that. Here is, or I'll link a Khan Academy video off to the side somewhere. Alright, so looking at difference of squares, remember when we're talking about squares, when we're talking about squares, we're really looking for kind of, when we're looking at the area of a square, like 5 times 5, that gives us 25, and that's kind of the basis behind factoring binomials. Because if we were taking a look at the area being 16x squared minus y squared, okay, then the side lengths have to multiply to give us that area. And the way that we're going to look at that is we're going to break each one down to see, okay, whoops, I already jumped my step here. We're going to see what number squared gives us 16x squared. And that's just going to be 4x. And then over here on the second term is just going to be y. Okay, so this is A, this is B. If I substitute into this formula, okay, we would end up with 4x minus y and 4x plus y, and that would be a difference of squares, because if we were to FOIL this back out or use the area model, it would actually give us the area on the inside, so 16x squared minus y squared. All right, so let's go ahead and take a look at the second one. I'm going to zoom in a little bit if it'll let me. There we go. Okay, and we're going to go ahead and change colors. Noticing 5 and 405, back up. Let's go ahead and take a look at, when we're talking about squares, we're really looking for perfect squares. And when I say perfect squares, I'm talking about 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 25, 6 squared, 36, 7 squared, that's just going to give you 49, okay, and so on. So we can say, okay, 64, 81, and continue on. Alright, so when I'm looking at these two terms, I notice that they're not perfect squares to begin with, okay, but I also notice that they both have a factor of 5 that can be factored out, and x squared, okay, so there is a greatest common factor within these two terms, and that's going to be 5x squared. Now when I factor out 5x squared from both terms, this would end up being 5x squared divided by 5x squared, which is just going to give us 1. Okay, don't forget to put your greatest common factor on the outside there. Alright, so when I divide out, and I'm going to put this up here so you can see it, okay, 405 divided by 5 is going to give us 81 x squared, okay. Now I notice that 1 and 81 are part of our list of squares, so we can go ahead and continue on. This would be 5x squared, always bring down that greatest common factor, GFC. No, goodness gracious. GCF. I know it's written right there. Dyslexia, my friends. Okay, so looking at this, we would start off with 1 squared. So that's just going to be 1 minus 9x and 1 plus 9x. Okay, and if you want me to break that down, I can do that down here. So it'd just be 1 squared minus 9x squared, and that would be a and b, and then we could use our formula up here as far as a minus b times a plus b, and that would give us our overall formula, our overall completing the square. Okay, all right, let's go ahead and take a look at, last step is to go ahead and take a look inside to see if there's anything else to factor out. In this case, 1 and 9, there's nothing to factor out other than 1. Okay, and for this next example, looking at 3 and 27, okay, 27 is more of a cube, but we're looking at squares for right now. Okay, and 3, there's not a square or a cube, so we need to go ahead and divide 3 out, because I noticed that our greatest common factor, okay, is 3 on this problem. So we're going to go ahead and 3 is going to go on the outside, x squared minus 9 goes on the inside, and we do have a difference of squares because 9 is a square and so is x squared. So when I factor that out, this is going to end up being x minus 3 and x plus 3. And then don't forget to bring down that greatest common factor, which is 3. Look on the inside, see if there's anything else that could be factored out. In this case, it's not. So this is fully factored, and you are done. All right, let's go ahead and take a look at the last example for completing the square, our difference of squares. And we have x to the 4th minus, x to the 4th minus 16. All right, so when we're factoring this, I notice that either of them do not have greatest common factor, so we're going to jump straight to x squared. What do I have to multiply? That's just x squared. So x squared squared gives us x to the 4th minus 4 squared, which would give us 16. Okay, so this is A, this is B. Setting it up, we have a difference of squares. Okay, so this is going to end up being x squared minus 4x squared plus 4. All right, now we need to look to double check, can it be factored further? Okay, looking at x squared plus 4, there's nothing I can do to expand that, but I can expand x squared minus 4 because that's another difference of squares. So we can go ahead and start off. This would just be x minus 2 because 2 squared is 4, and x plus 2. And then we're going to go ahead and multiply that by our remainder binomial here, x squared plus 4. Nothing else can be factored out, so we are complete with that. All right, so when we are simplifying factoring by quadratics, we need to see, first of all, first step in factoring, see if there's a greatest common factor. Okay, I noticed that all 3 terms, okay, are even first, and then I also noticed that each one has a variable. Okay, so if they're even, I can see if they are divisible by anything else, but I don't notice that they are. But I can always divide by 2 if it's an even number. So I know that the greatest common factor is 2, but I also notice that they do share a variable x. So let's go ahead and divide that out. If I see anything later on, I can divide that out as well. Okay, so this is going to end up being 3x squared because I divide out one of those x's. Don't forget your greatest common factor. Okay, minus 32 divided by 2 is going to give you 16. X squared divided by x gives you x, minus 24 divided by 2 gives you 12. X divided by x gives you 1. All right. Now we can factor this further, and the way that we're going to do that is actually factor by grouping. We're going to spend a little bit more on the next lesson by factor by grouping, but this is something, this is something you do know how to do. All right, so we're going to go ahead and take a look at A, B, and C, and we're going to go ahead and multiply A and C together. Okay, so we're going to see what A and C are. In this case, it's going to be 3 times 12. 3 times 12 is just going to give us negative 36. Now, negative 36, when we multiply those two terms together, we need to go ahead and see what will add up to give us the negative 16. Okay, so what are the two factors of negative 36 that'll add up to give us negative 16? And some of these are trial by error. So we're going to end up with 6 times 6. That doesn't, or negative 6 times negative 6, or positive. That gives us 0, so that's not going to work. So we have to keep going. My next one was negative 3 times 12. That doesn't give us negative 16. So I had to keep going until I ended up finding negative 18 times 2. And that, whoa, that's an ugly 2 here. Equals negative 16. So that worked. So when we're factoring this out, we're going to end up with, bring down the GCF, bring down the first term. This middle term, we're going to end up splitting. So that's going to end up being negative 18x plus 2x minus 12. The next thing that we're going to do is we're going to go ahead and split them, or we're going to factor by grouping, and we're going to see what terms or what can we divide out of the first two terms. Bring down that GCF. Out of these two terms, I notice that they both have a variable, x, that can be factored out, and 3 and 18 share a common factor of 3. So when I factor the 3x out of 3x squared minus 18x, that just leaves us with x minus 6. All right, now the next two terms, we're going to end up dividing out a positive 2, and what we would be left with is x minus 6. Now the next step is we need to go ahead and notice how these two binomials are the same. That's exactly what we want here. So we're going to bring down the greatest common factor multiplied by 3x plus 2 times, let's do a different color here, times x minus 6. All right, and that's as far as you can go, because looking inside the binomials, there's nothing else we can factor out. Okay, and like I said, we are going to practice a little bit more of how to factor by grouping. Okay. All right, let's go ahead and take a look at this next example. This next example states 2x minus 7. X plus 12, and we're going to need to factor that completely. All right, so what we're going to look at first is to see, here's A, B, and C, and we need to see what A and C factor out. There's not a greatest common factor, so we wouldn't have anything else to factor there. Okay, but we need to see, also, whenever A is 1, you can multiply AC out and go ahead and figure that out, but I just realized that this is an easier problem. Okay, you just need to take a look and see what are the factors of 12 that'll add up to give you negative 7. And in this case, we can take negative 4 and negative 3 and multiply those two together, and that would give us our positive 12. Okay, so x minus 4 and x minus 3 would multiply to give us that. When we add them together, that would be negative 7x, but when we multiply negative 4 times negative 3, that would just give us a positive 12. There's nothing else that needs to be factored out of those two binomials, so you are done. Okay, if you have any questions, please don't hesitate to ask. Please let me know if you need any more extra resources. Otherwise, I hope you guys understand this. If not, please let me know. Okay, have a great one.